Okay. All right, it seems they've worked it out. Hi everyone, my name's Sam. I'm a Google developer expert for machine learning and deep learning. I spend most of my time working about deep learning and language and dialogue. I've also been involved in quite, stuff to do with startups most of my career. I'm based in Singapore, but ผมพูดไทยได้ครับถ้าคุณอยากถามภาษาไทย All right. So the startup that I'm working at, or the startup I'm one of the founders of at the moment, is a startup called Red Dragon AI. And we do a lot of things related to deep learning consulting and prototyping for sort of big companies as well as some other startups around the world. We also do education and training. And we also do some products that we're sort of doing in stealth mode that relate to things to do with conversational computing, sort of like enterprise versions of Google Assistant and things like that. Okay, so today, let me see if I can make this bigger. Today, what I want to do is sort of walk through a little bit about building an AI product and the steps that it takes to actually make some sort of AI product, discuss some of the challenges, and show you sort of like some real world examples. Because I find that a lot of people are really good at doing like Yuri mentioned, either Kaggle competitions or running MNIST or things like that. But when it comes to actually taking those skills and trying to build a real world product, it doesn't often work out so well. So you'll notice all these products are Google products. Every single one of them extensively uses machine learning. In fact, inside Google, almost all the products now extensively use deep learning. So this slide was taken from almost 2 years ago, and it shows basically the acceleration of deep learning and TensorFlow repositories, or TensorFlow code, inside Google's sort of index of repositories and folders. Actually, the number at the moment is well over 6,000, 7,000. Folders inside Google's repos that contain TensorFlow code. So, what are some of the challenges that you face when doing this? One of the biggest things is just sort of deciding what's possible and what's not possible. So a lot of times we get people coming to us and saying, okay, can you build a deep learning model that does, that just sort of looks at what I want and works out straight away what I want, right? A lot of people, especially product managers, have no clue about what this technology can do and what it can't do. And often and it works both ways, right? Sometimes they will say, okay, I wanted to do something which just, is basically the equivalent to AGI or artificial general intelligence, as we're nowhere near it yet. Or they will often underestimate what it can do as well. So I think, certainly in your role as say, a machine learning engineer or a data scientist, you should know some of these sorts of things. So one of the questions to ask too is like, has someone else done this before? Is there data available to do this? That's one of the biggest problems that we get a lot, is people say, well, I want to do this, and it's technically possible, but then we point out to them that, well, you're probably going to need at least a year of data from your business. Have you collected that? No. And a lot of the times, the conversations that we have with people are just sort of getting them to understand what data they need to start collecting, and then we'll come back and see them 6 months later, kind of thing. Synthesizing data is a big thing. Today, in the example I'm going to give, I'm going to show you some examples of synthesized data as well. The other thing too is that, kind of like what I mentioned before, that when you're actually building and prototyping AI products, it's very different than sort of the academic track or the research thing. It requires a lot of sort of creative thinking, we can call it. So, okay, let's look at some of this. One of the things you want to ask yourself is, okay, how can this task be broken down into various parts? What sort of problem is this like? I think for a lot of people, they understand, okay, that certain models can deal with certain problems, but they're not so good at sort of looking at real-world problems and then working out, okay, what kind of models would I use to do that sort of thing? So often you want to ask yourself, is this a classification problem? Is it a regression problem? Is it a generative problem? What kind of model would I use for this? The other big thing that I would say is ask yourself, can this be turned into a classification? So we all know that, like, classification often is going to be much easier than generative modeling. Yet most people don't think about that. So a classic example of this inside Google was Smart Reply. So how many of you know Smart Reply on Gmail and mobile? Pretty much everyone, right? So this originally started out as a paper that was a generative model. It was a sequence-to-sequence model that basically read your email, read the subject and stuff, and based on that, it would then generate 3 possible replies. And the problem, one of the biggest problems with that model was that it would often tend to sort of just pick replies that were most common. So almost always one of the 3 replies was, "I love you," which probably wasn't a great suggestion for business emails and stuff like that. But so when the first sort of academic paper came out, that's the model that was used. Now, here's the thing, the actual version that's in production today doesn't use anything like that. What they basically did was turn the whole thing into a classification problem. And they basically have around about 29,000 classes of responses that they predict. So they basically read your email, read the subject text, read a few other things, and then they basically do a sort of prediction to work out what are the classes, and then they do a sort of like a ranking of those to basically determine, okay, what are the best classes to show someone for this kind of email. And that's a classic example that you see a lot of where something that in the academic way is done in a really complicated way, a really novel and interesting way. Often when it gets to production in a big company like Google or something, it's got to be in a way that's going to be robust. Right? Probably, how many of you remember the problems that Microsoft had with the bot Tay? Where it got, suddenly was generating all these racist answers and things like that because it was a generative model, right? So you've got to be very careful about those sorts of things when you're looking to build real-world products. So what I want to do today is sort of just show you an example of, a couple of weeks ago I was thinking about, okay, well, what's a product that I could build that I could show you in sort of like, a short time of how this works. So this is what we want to do. We want to basically draw a picture and then use that picture to basically draw a website or make a website and actually write the code for us. All right? So this is actually it comes from a paper called Picks to Code. And it came out, I think it came out about September last year. It did get quite a bit of press when it came out. And basically what they were trying to do was show that you could take some sort of drawing or some sort of wireframe. Actually, their paper was about wireframes. So it's actually kind of proper laid out wireframes. And then take that and use that to generate code. So partly because I'm lazy to do wireframes, I thought, okay, really what you should do is you should just open something, draw something, and then it writes the code for you. And this is especially true in our company because we're not big on websites. So one of the jokes inside of our company was that, okay, this would be fun to do, to help us actually finally get a website that is a public-facing website. So what's this problem like? This is one of the, I want to sort of take you through some of the thinking that I use to do this kind of thing. So the first thing that this is kind of like would be image captioning. So this is a very famous model called show and tell from a few years back, that again from Google, that basically what it was trained to do was look at images and caption them, right? Just basically write a sort of sentence-long description of what's going on in the image. And if you look at this, you can basically see, for example, the one on the right there, the model has learned that if it sees like a human on a beach and it sees a kite, that it's highly probable that the person on the beach is actually flying that kite. Given enough data, this model can basically learn to sort of write pretty good descriptions of different images. So notice here, this is still a generative problem, right? This is what we're doing here, is we're basically taking some form of input, which is an image, and we're going to try and generate text out of that. So the next thing that this is like, is for those of you who were here when I presented last month, when I talked about NASNet and the neural architecture search. This problem has elements of that in it too, in that neural architecture search was basically about working out how to build the best CNNs, using reinforcement learning to build the best CNNs in the world. And one of the ways that they did it is that you basically have to predict some sort of config file, right? Because you don't want a model that's going to just write all your code for the CNN. What you want is a model that, for example, here, each output that's coming up there, one of them might be the number of filters in this particular layer. Another one might be, the filter height, the filter width, the stride height, whether you're going to have max pooling. All those sorts of things are things that you can turn into a config file, which then you can use some sort of compiler or some sort of parser to actually build into a CNN. Another thing that this is like, and I'm not sure how many people know this here, is the famous model called char-RNN. How many know char-RNN? So it's basically for generating text, that you basically train a model, and in this case I trained it, I haven't got examples of the text, but okay, in this case we trained it on Shakespeare. And basically, given a short element of text, the model can learn to continue writing text that is like Shakespeare based on that. Now, the challenge with something like this is we don't really care. There's no right or wrong answer coming out. Right? This is where this is different than what we're going to do in this case, is that when we're predicting something generative like possible text that Shakespeare could write, there's so many right answers it doesn't matter. But what we want is actually a way to basically get from drawing through to code. So, okay, how does it work? So what we're going to do is we're going to basically take two types of data. We're going to take images, and we're going to take these sort of GUI configs that are a representation of what that particular HTML page would look like. And we're going to feed it into first a CNN for the image and an LSTM for the text. We're then going to basically tokenize it, and we're going to use an output which is going to predict tokens that would be elements of an HTML page. And then basically we're going to do the normal thing that we do with a neural network, take a loss, gradually change the weights in all these things over time, and get something that's going to produce a result. So we're using the CNN as basically an extractor in this case. We're making a config file, and then we're going to basically tokenize that to get a vocabulary. And we want that vocabulary to be as small as possible to be able to be accurately predicting elements of things that are represented on the page. And then we're going to basically use those features and feed them into an LSTM, which it itself is going to basically turn this into a classification of predicting what is the most appropriate next token based on what I've seen so far, from the image and from the actual sort of other tokens I've seen. All right. So, and one of the big things is what we do is we convert this, we convert these classifications into a domain-specific language. So you'll see this. I'm going to show you some code in a bit too, and we'll actually go through it. And then we basically take those tokens and we basically want to compile them or convert them into raw HTML. So one of the key things to understand here is that if we just tried to do HTML alone from the start, the model would have to be so much more complicated that it would basically, it's probably be impossible to do. So let's look at the architecture. So I mentioned before we're going to have an image extractor or image feature extractor. So it's going to look at that drawing and basically sort of work out, okay, what are the key parts of it? We're going to have a word encoder, which takes those words from a GUI file. And then we're going to have a decoder, which is going to turn all this back into tokens. And then our compiler is going to turn those tokens into HTML. So this is actually what the architecture looks like from their paper. All right? And you can see, while it may look like it's a complicated model, actually in many ways it's a pretty simple model. We've got on one side a CNN, on one side an LSTM, and then we've got both of them going into another LSTM, which is going to basically then make our predictions. Now, I don't have time to go in and explain how LSTMs, and I'm hoping that most people sort of understand some of those things. Then the key thing, one of the real key things for this is basically the whole concept of the compiler. So this is a real sort of trick of the trade for doing a lot of these kind of problems, is that you want some sort of compiler that can basically take these tokens and turn them into something else. So for example, even no matter the best LSTM that we use is probably the NAS-cell RNN, which again was created by the neural architecture search. That itself wouldn't be able to produce raw HTML in a way that would be good enough for what we need. For example, we know with HTML we have to open tags, we have to close tags, right? So that means whenever we open a tag, the model has to remember that it's got a tag open, and it's going to have to close that tag at some point in the future. Now, we can do that with the token system because we're trying to keep the vocabulary and the amount of tokens as small as possible. If we did it with raw HTML, we might have thousands of characters, and the model's just not going to be able to remember to close everything that it opens, that kind of thing. So the key thing is to understand that these DSL tokens that I showed you before, that were coming out, are going to be converted into HTML. So here's an example of a config file. So this is what we want to predict. Right? So this is basically a config file that represents an entire HTML page. Right? So if you look at it, you can sort of see that, okay, we've got some sort of start token. We've then got a header. We've got some buttons going on at the top there. Notice that, okay, so you see where the curly brackets are? Each one of those is a separate token. So the model predicts, for example, start, header is a token, curly bracket is a token, button inactive is a token. All these sorts of things are individual separate tokens that are going on here. And then what we want to do is basically take that and use some form of sort of compiler. Now, the compiler is really simple. It's just a parsing engine that basically looks at some other JSON file and says, okay, if I've got button inactive, what's the snippet of code that I should be showing for button inactive? So it basically just takes these chunks and sort of expands them out into code. So this is an example of a template file, which we would use to basically turn that GUI language back into HTML. So hopefully everyone's starting to look at this, right? And I see a lot of people starting to nod their heads, which is good. Okay, so this is really one of the sort of crucial bits. And it's something that most people would not think about when they're actually sort of trying to build a model like this. They will go straight for building the whole raw HTML from scratch. So data. More is always better, right? So with an issue like this, there's no data set that you can just go and easily get. And this is one of the problems that you find with a lot of this stuff too, is that you need to find ways of synthesizing data. So often you're going to have to sort of like find some way of manufacturing data when it just doesn't exist. This is a big common problem at Google, at most companies. The advantage that sort of Google, Facebook, Baidu have is they have so much data, and they also have such a good user base that they can basically build a product purely to get data. And this is happening more and more. Andrew Ng from Baidu has confirmed that multiple Baidu products that they've built had no intention of making money, had no intention really of anything except for basically getting data, which they would then be able to use to build better models for other things. So I noticed this morning that my Android phone was asking me to review the hotel. And it said, can we ask you some questions about the hotel? So it asked me, did it have a gym? Did it have, it's basically using me as a human in the loop to collect all this data about that hotel, which they will then aggregate over a certain number of people and get a good picture of what that hotel is. So this is by far the biggest challenge you will often face. You need to often one of the big things you're going to do is learn to create tools yourself for making or collecting or annotating data. This is something that that often I'm sort of building small tools to either scrape stuff to get data or that kind of thing. Okay, there are also often some opportunities to use unsupervised learning or semi-supervised learning to basically take a small amount of labeled data and turn that into a much larger set of labeled data. I don't have time to really sort of go into how you do that, but that's something that you should be looking into as well. So I said before that the more data you've got, the better. In this particular case, we want the data that's basically going to simulate what someone draws. Also, don't fall into the trap of making, for example, with images, you don't want to basically make a whole data set at a certain resolution and then come back and realize, oh no, it was too small a resolution, we need to make it all again from scratch. Go for a much bigger resolution at start and then just downscale for whatever you need. Okay, so we've basically got, for this, I actually had, let me talk about this. So at the start, one of the things I thought I could do was, well, maybe I don't need to get people to actually draw it, I can just fake it somehow. So I started looking around, could I make websites, or could I make, take like my sort of GUI template, turn that into a website, but do it in a way where it renders with CSS that looks like handwriting or looks like, that it was drawn by some person? The simple answer is not very well. Because the challenge is that it's going to end up being too much the same each time, that the model won't learn the variations in the way that people draw things very well. All right, so that's one of the things that I found. So basically, what I did was I got one of my staff to just draw a lot of these websites. And here's some examples of drawing. And after someone's drawn a few hundred of these, they're not in a happy mood, but at least you've got the data set that you wanted, right? And so basically, yeah, I ended up having 2 people sitting there drawing these sorts of things for a couple of days this week to get it to work. Then basically, okay, so I'll talk about some prototyping. So some key things about prototyping is that you want to map out the product workflow. You need to understand you're making a product, you're not making just a model, you're not just making something to win a Kaggle competition or something like that. You want to break it down into sort of each part of the model. I always start with transfer learning. So whenever I see a CNN, for example, in something like that, first thing I do is I just go and pick a CNN off the shelf with great set of weights from ImageNet and see, will it work? Can I get something working with something like that? Just like James showed with TF Hub, it's a proven fact now that any weights that have been trained on something that relates even remotely to your data is better than just random initializations. So by starting out with some sort of transfer learning of the CNN in this case, I was able to work out, yeah, okay, this could probably work, but those particular models were too big. Right? It's no point in having like an Inception v3 or a NASNet or even something like a NASNet for this problem, because it's just too big. It's going to make the processing time take forever. Okay, so the other thing you want to think about too is like, okay, the actual UI of how is this thing going to turn out, right? So now we come to the fun bit of where things may break. All right. Okay, people cannot see my screen. How do I do this? Is there any way, or am I just going to drag it across? Okay, which means I need to sort of look up here.
I think just mirror your screen.
It's not showing up on Mirror for some reason. Okay. Aha. Now, where did it go? Okay, great. All right, can people see the code? All right. All right, so this is an example of an image that was from the test set, right? So the model hasn't seen this image. I'll show you that to you ahead of time, just so you see the full thing. All right. Okay, so when you're basically prototyping, for me, how many people know Jupyter Notebooks? A lot of people? Yes, great. Okay, use Jupyter Notebooks or something like that where you're constantly going to be changing things. You just want to get things working quickly. So in this case, I've actually abstracted the model out here, but and I've done it in Keras, so it's very simple for you to read. How many people know Keras? So Keras is the high-level API of TensorFlow. It's probably the main one that especially if you're reasonably new to deep learning or anything like that, you should certainly start out with Keras. So one of the cool things with Keras is we can basically do a model.summary and see what's going on here. And you can see we're basically going, this is actually coming out of the CNN. We're basically going in to the LSTMs, or in this case, GRUs, and we're going to make some predictions. So let's take this image that we've got here. All right, so you can see that I've just loaded up this image, which is in the back here. All right. Now, the first thing we want to do is get our tokens. So remember I talked about, the tokens are limited. In this case, we've only got 18 things that we can predict in this model. We want to just basically be classifying one of 18 things as the next token. All right, and you can see what those things are there. We can then basically take that, and this is sort of like a part of the compiler part. So we're going to basically just go through, make a prediction of the next token at each time step, and then use that as the input to basically predict the next token. So let's run this and see if it's going to work. OK, so you can see it's basically going through, and it's predicting a GUI there. Now, when it gets to an end token, it just stops, right? So if there wasn't the end token there, it will keep going for 150 steps. But if it gets to an end token, it will just basically stop. All right. We can then take that and start to now compile, generate some HTML out of that. And this is what we get in this case, which has saved it. And I will just refresh it. You can see there. Now, so this is basically generating raw HTML. Compared to here, we've got our 5 buttons. It basically generates some random text. The text is just made up. Obviously, the text on the buttons is button. All right. But I know, like, if I was you, I would be sitting there thinking, he could have done this before. He could have faked it. I'm a suspicious guy. So the next part of that is that also, remember I talked about you want to think about, OK, what's the workflow going to be like? So in this case, one of the things I was trying to do for a workflow was that you've got a web page, and people can draw on this web page. They can just draw anything. And they're going to basically draw something, and then it's going to take them, so how many Flask? All I'm using is Python and Flask. At the back end, it's going to take this JavaScript canvas, turn it into an image, upload it, use that image then to predict something. So let's see, how many buttons should we start off with? This is really hard for me to draw on a trackpad, by the way, too. So I think the sort of final idea for this was that I would eventually get it live on a server, and I'd use an iPad to draw it. Right? So it may not work that well with my drawing like this. Let's add another button. Ooh, I've messed it up. That's really bad. All right. OK, so let's go for 2 buttons. Then let's go for 2 sort of medium boxes. How about there? All right. That's not so good. Put a little bit of text in here, so I want a title there, and then a little bit of text. And I'll go for another medium box. Again, a little button. Better put a bit of text there. A title. OK, let's try this. Now, I have no idea if this is going to work. So basically now it's just it's using Flask. I've got Flask running on the machine as a server. It's going through, it's processing it, it's doing the whole thing, and then it basically comes back and says, this is your HTML page. Let's see, are you ready? Whoa! And we can add more to this, right? We can add, like, let's say, okay, we didn't like that design enough. We want to add, let's push our luck, right? This is called the bit where you should have given up while they were all clapping. All right, so, okay, I want to have maybe some, I want to have sort of 4 boxes now. Now, while I'm drawing this, I'll just tell you that so one of the things that I didn't get finished in time was the ability to actually, I want to have put like a button on the side that basically what you will do is then select what sort of CSS you want as well. So you could have, you can see I'm using Bootstrap here, but I could have material design, I could have like a whole bunch of different things. Hang on, talking and drawing at the same time is not my strength. All right. Oh, that's not good. All right. But this is, in some ways, this is like what you want to do is you always want to sort of stress test your models and your product as much as possible. Because trust me, whenever you build something and put it out into the wild, people will try and do everything they can to break it. All right? All right. So now we're going for 2 medium ones, 4 small ones. Let's really push our luck and try for 1 long one. Okay. So everyone understands what's going on here, right? The model is basically looking at this through a CNN and then trying to work out all the features and then basically turns that into a big sort of matrix, which we then run through our STM. Okay, let's try this again. It's thinking, it's thinking, it's thinking. And, whoa, okay. So it's basically, it's been able to pick those things up, right? One of the things that's missing in this model, and I may, if you're coming to the AI Day next weekend in Singapore, I may actually have it added by then, is the ability to basically put in images or something and maybe draw something that will be an image. And then it will actually go and find sort of, some sort of stock photo and stick it in there and do that as well. All right, so to finish up, okay, where to from here? So this is still basically a prototype, right? But it is a prototype that you can see that, okay, just drawing, now we can basically take it and turn a drawing into, and one of the things maybe I didn't show you is all of that, in fact, let me show you that. All of this is just HTML code. So, in fact, yeah, let me do view page source. Right. You can see this. It's all been turned into sort of normal HTML code, in this case with Bootstrap, with all these things. And all of these things are basically, the token is using it to transfer that into a snippet of HTML. Right. So where do we go from here? So one of the big things that would be the interesting thing to do is to basically decide, okay, should this be sort of like a web model or or something on mobile? Maybe it should be something that you just draw on a piece of paper and then take a picture with your phone and it develops the code for you. Another key factor of thinking when you're taking something and putting it into production is whether you're going to make it sort of like a microservices architecture or a monolith architecture. So in this case, I've just used basically Flask and done the whole thing in Flask. In the real world, I'd probably want to use something like Node, have some sort of queuing system, which would then go into it. I might be using something like TensorFlow serving to actually run the model. Or I could use just like a normal sort of REST API to go in and run the model. You would want to think about, do you want to use a GPU or not? You notice that, okay, running it on my CPU, there was definitely a lag, right? So this is the sort of time you would basically go to your production, your product managers and sort of talk about, okay, what's the acceptable lag time between the time the person presses the button and they get their fully completed HTML code. You also want to think about things like cost. So, okay, how much is this going to cost per API call? How much compute is going on and stuff like that? While these things may not seem big things at the time when you're sort of designing something, they often end up becoming really a big deal. This model, if I was going to put it in production, I would want to reduce its size so that it basically runs faster and is going to cost a lot less in compute to make happen. All right? So the mobile version, if I was doing a mobile version, then we'd probably look at something like TensorFlow Lite or Core ML and try and get the model to run nicely on a phone, which in this case, it probably would be able to run, but it's probably going to run too slow for anything but the latest phones. So maybe your iPhone 10s with a bionic chip or something would be okay, but others wouldn't be. You'd also want to think about practical things of like, okay, in this case, where do we want to deploy that HTML code to? And often, if when you as a startup or something, often this is where you're going to make your money. Maybe you're going to deploy it to some sort of place where they can only access it if they're a member of your, of your particular product or something. So it requires people to tie people in, something like that. Business considerations are a big factor. So just because something can be technically great and be a really cool sort of AI application, which I kind of feel this is a cool application, it's probably not going to be a great product. And would people pay for this? So at the moment, I would say no. Right? That while it's a cool prototype and stuff like that, it would probably need to be a lot better because the people who would most likely be your customers are people who know nothing about HTML and CSS. So even having a drop-down for like Bootstrap, material design, whatever, they're going to think, well, what's that? I don't know what that is. Right? So you've got to think of those things. Is it a painkiller or a vitamin? Often we talk about. And really, does the ML or the AI one of the biggest dangers that I see a lot is that us as engineers get really enthralled in like the AI part of it or the ML part of it or the deep learning part of it so much that you think, oh wow, this is really cool, and you forget that probably the end user doesn't give a crap about this stuff, right? So, okay, a few things I'm going to finish up. Some tricks of the trade that I want you to sort of understand. Play to your strengths. So I can't tell you, I'm not going to break any NDAs that I have with Google, but I will tell you that Google is the king of search, right? Everyone knows this. And they tend to take things and turn them into search problems. They're very good at like retrieve and rank and those sorts of algorithms, at being able to take a whole bunch of things and work out and predict what's the best thing out of that. A perfect example would be Google Home, which is coming to Thailand soon. Which is basically a big search engine, right? The way a lot of it works is using sort of retrieve and rank technology of finding things and then ranking them and then picking the best. And you'll often see if you take sort of Google Home and Google Assistant and ask them the same question at the same time, they will deliver different results because they are doing split tests on working out what's the best response for that. The other thing I would say is play to your data. So I talked about this earlier on. At the end of the day, make things that you either have data for, you can get the data for, or you can create the data for. Far too often I see people who have great ideas, but they just don't have the data to back it up, and that's frustrating, right? That's really frustrating. A classic example of this I see a lot is with startups is medical data. Is people think, oh, I can make this fantastic, CNN thing, which is going to basically, take all these mammography scans and find all these things and stuff like that. And then when I talk to them, okay, well, do you have access to that data? No. Right? And the chances are it's going to be really, really hard to get access to a lot of that kind of data. Especially now with, I don't know if you guys have been following it here, but with the whole sort of blow up of, Facebook in America and the privacy concerns with Facebook in America, everyone is becoming, really tight with their data. So no one's going to want to share data with you. You've got to get used to that. Here's some links, and I'm happy to take some questions. That's it. Thank you. Any questions? No? Okay. Who's up next? Ken? Do I have a GitHub for the code? So this is the code from the original paper. It doesn't do a lot of the fancy things that I'm doing. Let's see. After next Sunday, I may put the code up on GitHub. All right. At the moment, it's just so messy, I would be embarrassed to put it up. That's the main reason I haven't put it up. Go for it. Can I go to the... Whoa, okay, I pulled it out at the wrong time. Haha. All right. Okay, what did you want to say this? The generated HTML? The? Okay, okay. All right. How do I do that? Actually, easiest I just come back here. Sorry? Ah, I made a mistake. It did make a mistake, yes. All right. Good question. All right. I wondered that as well. All right. All right. What if we do 4? No, I'm going to take that. So I'm happy to show it. Anyone who wants to come and ask questions or anything, or come play with it. Any other questions? Okay. Why do I worry about the? Oh, okay. Okay. For the mobile compatibility, meaning that whether the model would run on mobile. Because if I was going to deploy it on TensorFlow Lite or Core ML, the model would actually run on the phone. So it wouldn't be using the cloud. It would be using the edge in that case. So I'd be basically deploying a model that would be running on the phone, and as the person takes a picture, it straight away is running the model. And then it might generate the tokens. Yes, that's a good example of where, for security reasons, you probably wouldn't want to generate the entire HTML on the phone. You would generate the tokens on the phone, JSON them up to the cloud, generate the HTML up there. But you would definitely, in that case, the reason why I'm worried about the compatibility is because I'd be running the model on the phone, not in the cloud. Okay. Any other questions? No? Okay.